Hello and welcome to this lecture where I will show you how to model variable delay. As you know, in the pound delay cannot be a variable. It must be a constant. So there are a couple of ways you may attempt to make this delay variable. For example, in this property, I'm showing a local variable LV. And then what I'm saying is, whatever data delay that I pass, store it in the local variable LV. And then wait from 0 to that value stored in LV and then do read data. Now this will give you an elaboration time error. Compile will pass. Because during elaboration, the simulator needs to know the delay. And if it's variable, it does not know the delay. So it has to be a constant. So this will give you an error. The other way you may try to model this is by simply saying that when read falls, wait for the read latency which I have passed into the property and then do read data equal to expect data. This also will give an error because read latency is a variable and it must be a constant. This is what the semantic specifies. So what if you do want variable delay? Let's look at this example. This is an example from CPU system where the level 2 cache can have different read latencies. So if the read is at the end of the queue, then the data will come with maximum latency. If the read is at the beginning of the read queue, data will arrive with minimum latency. And anything in between, data will come with that in-between latency. Now we know that we cannot write a property where I can pass a variable latency and let it wait as long as it's supposed to wait. So, there are ways that you can handle this variable latency. One is simply creating, let's say there are 100 latencies, 100 different properties, each with a constant delay from 1 to 100. Would you do that? I don't think so. That's not a clean solution at all. Or someone can say, well, I don't care for in-between latencies. I will create a property with min latency and max latency. Well, in mission critical applications, this will not work because the in-between latency also is just as important. So how would you solve this problem? Well, local variable again comes to rescue. And this is how it works. So what I'm doing is, in the property read latency check, I'm passing it a variable latency read latency. Then I'm creating a local variable called LDelay. Then I'm saying that at every passage of clock, whenever read falls, store the read latency that I've passed in this property and store it in the local variable LDelay. Then at every clock, I'm going to decrement this latency, LDelay, by doing this particular small sequence here, saying that always, because it's always true, at every passage of clock, decrement the local variable LDelay. And keep repeating this, keep decrementing LDelay at every clock with a consecutive repetition operator, meaning keep subtracting LDelay forever until LDelay is equal to 0. So for example, let's say read latency is 3. At the next passage of clock, it will become 2. Then at the next clock, it will become 1. And then at the next clock, it becomes 0. And this particular sequence will end. So this is the way you can easily create a small property where you can check for read data equal to expected data based on variable latency. This is a very good use of local variables. So do visit this slide again and make sure you understand this, because this will be a very useful application where you can indeed have variable delays in SystemVerilog Assertions. So that's all for this lecture. Thank you.